Hey, think about the last time you looked in a mirror. I mean, it's something we do every single day, right? It's just this simple, everyday object. But if you ever really stop to think about what's going on about that, well, that kind of magical person staring back at you? No, seriously, how does it do that? How can a totally flat piece of glass create this perfect three-dimensional copy of you? It feels like it has to be some kind of magic trick. But what's really wild is that it's not. The reality is actually way more incredible because it's just pure, elegant physics.
So, okay, what is the mirror's secret? Well, it all boils down to one thing: the physics of light.
And believe it or not, it all starts with you. See, whether it's sunlight or just a light bulb in the room, there are these invisible rays of light hitting you all the time. They bounce off you and just scatter everywhere. But when some of those rays happen to hit a mirror, they bounce off again. Only this time, it's not random at all. It happens in a very, very specific and organized way.
Yeah, this bouncing thing, it's not just happening by chance. It actually follows one super simple, completely unbreakable rule of physics.
Now, to really wrap our heads around this rule, we need to get on the same page with a few key players. Think of them as the main characters in this little drama of reflection. Okay, first up is something called the normal. Now, you can't actually see it, it's just an imaginary line that we use for measuring. We draw it sticking straight out from the mirror at a perfect 90-degree angle, right at the exact spot where a ray of light hits. This line is going to be our all-important reference point. Okay, next up, the angle of incidence. Sounds fancy, but it's really simple. It's just the angle between the light ray coming in and that normal line we just talked about. Basically, it's the angle in. And you probably saw this one coming, the angle of reflection. You guessed it, that's the angle between the light ray that bounces off the mirror and, again, that same normal line. So that's our angle out. All right, so we've got our players. The light coming in, the light bouncing out, and everything is measured from that normal line. The entire secret, the whole magic trick behind every single flat mirror on the planet, it all comes down to one beautiful, simple rule that connects them. And here it is. You ready? The angle of incidence is always equal to the angle of reflection. That's it. That is the entire law. So if a light ray comes in at a 30-degree angle to that normal line, it has to, without fail, bounce out at 30 degrees. No ifs, ands, or buts about it. This one simple rule is the key to the whole mystery. Okay, so we have the rule. Angle in equals angle out. Simple enough. But how does that simple rule create the incredibly detailed, perfect reflection you actually see? How do we get from just a bunch of bouncing light rays to a complete picture of you? Well, this is where it gets really cool. See, the image of you, it isn't actually on the surface of the mirror. In fact, it isn't really real at all. Your reflection is a fantastic illusion, and the magician creating it is your very own brain. So here's how the trick works. Let's say light bounces off the tip of your nose, hits the mirror, and then reflects off following that angle in equals angle out rule. Your eye catches that reflected ray. But here's the thing. Your brain is hardwired to assume that light always travels in a perfectly straight line. So it takes that incoming ray and traces it backwards in a straight line behind the mirror to where it thinks it came from. And where those imaginary lines meet up, well, that's where your brain decides your nose must be. Now imagine this happening for every single point in your body, all at once. Your brain pieces it all together and bam, you get a complete image that looks like it's floating there behind the glass.
So this process creates what you could call your virtual twin. And this twin has some very specific, very predictable characteristics.
First off, scientists call this a virtual image. And this is a really important idea. Virtual just means you can't like project it onto a screen. If you stuck a piece of paper behind the mirror where your reflection seems to be, nothing would show up. Why? Because the light rays aren't actually there. They only appear to be coming from that spot.
Okay, so it's virtual. What else can we say about this twin of yours?
Well, because of that simple law of reflection, the geometry works out absolutely perfectly. Your virtual twin is the exact same size as you are, not bigger, not smaller. And the distance it appears to be behind the mirror is the exact same as your distance in front of the mirror. So, if you take one step back from the mirror, your reflection takes one step back too. It's a perfect match. So, the big takeaway here is this. That one single, simple rule, angle in equals angle out, is what creates this perfect virtual twin. It dictates that the image is the same size as you and the same distance away, just behind the mirror. It's all because of that one rule. And that just shows you the incredible power of a simple law of physics, right? But it also leaves us with a really fun question to think about. If all of this perfect symmetry is what happens when a mirror is perfectly flat, what happens when you start to bend the rules and, bend the mirror itself?